In this video, we're going to continue our study of number systems with the binary number system. In the video, we'll review the decimal number system, learn the basics of binary, convert binary numbers to decimal, convert decimal numbers to binary, see a few important notes on binary, and summarize what we've learned. In our last video, we saw that the decimal system is the system that we use every day. It's known as base 10. It has 10 digits from 0 to 9, and the place values are powers of 10. In a number that has 2 or more digits, each digit has a value of itself times the place value. So in a number like 322, that means we have 3 hundreds, 2 tens, and 2 ones. And we know that this is not new to us, but it's a good thing to review before we go into the binary system. The binary system is base 2. Since it's base 2, we know that there are only 2 digits available in the system, 0 and 1, and the place values for binary are powers of 2. Normally when I teach binary, I use 8 place values, like this. 2 to the 0 power is 1, because anything to the 0 power is 1. The next place value is 2 to the first power, which is 2. 2 to the second power, which is 2 times 2, 4, and so on. 8, 16, 32, 64, and 128. Let's take an example of a binary number and see how it works to convert this to decimal. Here's a number, 11001010. Let's write the place values beneath it and use that to figure out what decimal number we have. This means that starting at the highest place value of 128, we have 1 in the 128th place, which means that that digit represents 128. We have 1 in the 64 place, so that digit represents 64. We have 0 in the 32s and in the 16s place, so those contribute 0 to our decimal value. We have a 1 in the 8th place, so there's an 8 there. We have a 0 in the 4 place, so that's a 0. We have a 1 in the 2's place, so that's a 2, and we have a 0 in the 1's place. So you can see on the right here that if we add all those numbers up, we get 202. So 11001010 in binary is equal to 202 in decimal. Another way to look at this is if we just add the place values where there are 1s on top, that will give us our decimal value. Also notice how I wrote binary and decimal in small letters as a subscript next to the numbers so that it was clear which number system each of those numbers was in. We'll learn other ways to distinguish between number systems separately from this video. In a moment, we're going to see how to convert decimal numbers to binary. But first, let's look at what the largest number we can represent in 8 bits. When you think about decimal numbers, you know that you can write any number you want. If you want to write 35,736, it's no problem. You simply need to use 5 digits. Same with binary, but for this lesson, we're going to stick with 8 binary digits. With 8 binary digits, the largest number we can write is where all the place values have a 1 in them. So if we write the place values below and add them up, like we did with the previous slide, we can see that the total value is 255. So 11111111 in binary is equal to 255 in decimal. So let's talk about conversions. Now you know that the largest number you can represent in 8 binary digits is 255. So the range of numbers that can be represented in 8 binary digits is 0 to 255. If a problem asks you to convert a number larger than 255 from decimal to binary, you'll know that you need more than 8 digits. To convert from decimal to binary, let's look at an analogy that will make it easier for us to see the process. In this image, you see a barrel on the left in blue. And let's say that you have to fill 175 ounces of water into the barrel. All you have to work with is these 8 measuring cups with different amounts of water. How would you do it? You can only use each cup once and then it's empty. In this analogy, the 175 is the decimal number we're trying to convert. The cups are the place values that we're going to work with. As we fill the barrel, if you use a cup, we'll write a 1 on top. If you don't use it, we'll write a 0 on top. After we add a cup, we'll figure out how much is left to fill to make the 175. Note, always start with the highest place value. We can talk about this in class, but always follow that process. We need 128 ounces to make 175. So let's write a 1 on top of 128 and fill the barrel with 128 ounces. With 128 in the barrel, we only need to fill a remaining 47. That is 175 minus 128. The next place value is 64. We don't need 64 to make 47. It would be too much. So we'll write a 0 on top of the 64. But we do need 32. So we'll put a 1 on top of 32 and fill the barrel with another 32 ounces. So how much is left now? 47 minus 32 is 15. And so we're going to have to keep going. To make 15, we don't need 16. So we'll put a 0 on top of 16. Now, as you can see, I've run out of space on this slide. But if you look at the remaining cups, you'll see that you'll need a 1 in each of those cups to make 15. So let's just jump to the end there and see that if we use this pattern of the cups, 1, 0, 1, 0, 1, 1, 1, 1, we will have achieved filling the barrel to 175 ounces. This is our binary number, 1, 0, 1, 0, 1, 1, 1, 1, that equals 175 in decimal. Here are some important notes about binary. Each binary digit is called a bit. It's short for binary digit. 8 binary digits is called a byte with a Y. It is a good practice to fill in the leading zeros in a binary number. For example, we've been using 8 bits in our examples. Let's say we want to write the decimal number 4 in binary. It's best to write it as 00000100 instead of just 0100. It's actually fine not to do that. However, it can avoid confusion. So let's just review what we've learned. Binary is base 2. There are only 2 digits, 0 and 1. In a binary number, the place values are powers of 2, starting on the right with 2 to the 0, which is the ones place. In an 8-bit binary number, the highest place value is on the left and has a value of 2 to the 7th power, which is 128. 8 binary digits is called a byte. To convert a binary number to decimal, add all the place values which have a 1 on them. To convert a decimal number to binary, you can use the barrel filling algorithm. That concludes this video on the binary number system. In our next video, we'll look at hexadecimal.